Welcome everyone back to decision trees and random forest, part of a machine learning class. Um, we're going to continue to start talking about the Jupyter Notebook, walk you through example. And our Canvas, the machine learning course module, download this Jupyter Notebook on the 07, decision tree and random forest, and also download the uh, hypothesis data set in the last one. So I already have it loaded up right here, and the Jupyter Notebook. Let's go over it. And we already have some introduction on how the decision trees and random forest works and Python in theory. If you want to have more and refer to our lecture video for the explanation, and also refer you to a blog, and you can have if right here by Jose Portilla, and to explain a little bit of theory behind it. So let's start this notebook. First, we load Python, pandas, NumPy, matplotlib, and Seaborns are for plotting. And then we get this data called kyphosis CSV file. All right, and take a look at this file. And stored in a data frame called df. And the file actually has a 4-column. The first column is kyphosis outcome. Is either absent or present, and either you have it or you didn't. And the second column is the age and the number and start. So there are 3 features and 1 outcome, and we're going to use this as our test example. Total about 80 data points in here, and we're trying to see if the age, the number, and the star actually can predict it either is present or it is not. Okay, it's fairly straightforward. And the data set was referring from Kager. I have a link in the PowerPoint for you. And first we do some exploratory data analysis. I'm going to plot this, and so what we wanted to do is, since the first column is the string type of information, and only consists of 2 separate ones. One is absent, one is present. We can actually convert this column into 0 and 1. If it's absent, we convert it to 0, and if it's present, we convert it to 1. So we convert the outcome of absent equals to 1, 0, and present equals to 1. And we can use 2 different methods, one using SciKit learn pre-processing called label encoder. Okay, we can convert that, and that's a fairly standard one we're going to use quite a bit in this lecture module. And we can do label encoder and fit transform, and it will automatically convert it. But we can also do it, I prefer, and doing manually, and I create a map. Absent is equal to 0 and present equals to 1. Then I do a panda replacement on the kyphosis column, specifically saying using this mapping I define. And after that, it will convert the data frame into, this column into 0 or 1. Then I can do some plotting. First is a count plot. We will see that we have more than 60 of them are absent, only less than 20 of them are actually present. So it's kind of a very unbalanced data set. And we can also do a pair plot among all the input. And we can see that, and between age to age, and then the data for taking any two dimension. We see how they overlap or not based on certain separation. Okay, so so these are the outcome of absence or presence, and the correlation of age to number, and if we transfer them into these two dimension, actually we have three dimension features, so I'm just mapping into two dimension. So this is a chart. We can see that there's no clear separation if we look at any two dimension. Okay, if we look at the one dimension only, there's no dominated features actually can clearly separate those. Maybe the number a little bit, and the star maybe a little bit, but it's not clear. So we can also do a heat map on the kyphosis and into all these other features, and the diagonal always 1-to-1 ratio, 1-to-100% correlation, and you can see from the outcome itself, from kyphosis to age is about 0.13, and kyphosis to the number actually is about 36.36 correlation, and actually kyphosis to the star actually is a negative 0.45. So it shows a little bit strong, okay, correlation between the outcome and the star point, but not quite exactly as a negative correlation. To do this was kind of a fairly messy data set, and there's no strong correlation between any of the features. So what we do is we're going to start splitting the test and the training set. I'm separating the entire data frame into X and Y. X is its features, Y is the outcome. So I drop the outcome column and give it to X, get all the features, and Y just get the outcome. And then we split the data set X and Y into using the trend test split function from the SciKit model, scikit-learn model, and using about 30% of them as a test. So 70% are training set and 30% are test set. We've done this quite a bit already in this lecture module, and this is pretty standard for either forecasting. We've done the last lecture module. Also, it is a fairly standard procedure for machine learning process. You're always using X to train, training set to train or fit your model. Then you're using the test set to evaluate the model outcome. Fitting is good. Okay. So first we're going to do a regular decision tree. We're going to using decision tree classifier from the scikit-learn tree modules. I'm defining the model called D-tree. Okay, decision tree classifier, and I'm going to fit that using the training set F, X, and Y. All right. Oh, sorry, I haven't executed this part. That's why giving me an error. And next we're going to do the prediction and the evaluation. So we're going to predict based on X test set and see and compare the prediction with the Y test set. And I'm going to using some of the metrics scikit-learn provide by default, and one we call a classification report. The other one is a confusion matrix. These are the two are the fairly standard ones we use to evaluate all machine learning type of outcome, especially classification type of outcome. And I'm going to print the classification report using Y test as one of the base to compare with the prediction. the model prediction. And we see that there is a precision, recall, and F1 score, and support, and all these number. I have some explanation at the end of the notebook. If you wondering what they are, actually there's quite a bit of a description we'll talk about later on. But these are the score or number actually representing how well the model predict and how they compare to the test data set. And we can also do a very confusion matrix, okay? And the confusion matrix, actually you see that true positive and false negative, actually they are okay. And there's some of the misclassification on the off-diagonal elements. One is true negative and is also false positive type of arrow. So here is the type 1 arrows. We have one of them. Type 2 arrow, I have two of them. And same thing, we can present it using a heat map for this matrix. Okay. It is a messy data set. I don't expect they have more than 80% of accuracy and precision. And I can show you how the entire using a SciKit learn tree, and we can plot for this example and how well the tree, but this is a little bit too small for visualization. So I went on to give you an example how to visualize much more colorful and meaningful tree. But this is using a so-called graphic visualization software. You can download it from this link right here and install on your computer. But you, unless you're doing a lot of graph theories and mapping type of visualization, you seldom use this part of the software. So I just put it here, all the code for you to reference later on. If you have to use this, you need to install this GraphViz, and it's a software installed on your computer. Then you install the corresponding Python API, and then you can call them directly from here to give you a how they split, okay, started, and how they end up with each one with decision. Next, we're going to talk about random forest. I think random we'll talk about in the PowerPoint presentation. A random forest is an improved version of a decision tree using a randomized sample and to make sure this, the first splitting, which is the root splitting, is not correlated. So we're using several possible splitting and trying to create a whole bunch of a decision tree and trying to see. Of course, this is a little bit more computational intensive. However, in general, the outcome is a little bit better. Okay, here we're going to using the SciKit it belongs to ensemble algorithm. There's a whole bunch of so-called improved version of a decision tree. Either we call it incremental decision tree, we call it ID3, ID4, ID5. And here we're just using an random forest classifier. It's one of the popular method people use to beyond the decision tree method. Later on, we're going to have we also discuss using a gradient boost method called gradient boost, gradient boost decision tree. Here we're doing the so-called random forest classifier and define the model and fit the model using the training data. Then we're going to do the prediction using the X-test data and compare the prediction with the Y-test. Very similar, and printed out the confusion matrix and the standard so-called classification report. So this gives us slightly better solution. And you say, hey, we only have very few data right here. Actually, these are all the data a test set has. Okay. Next, we defining so-called X gradient boost. First, we introduce a very popular library called XGBoost, XGBoost, and basically stands for gradient boost, and we can talk about it, and we show you how to install that using pip install, and after that we can import, okay, this model. And I haven't installed this. Let me do this, see if I make sure we've done that. Okay, after take some time to install the XGBoost, and we can import the XGB as XGBoost as a library. Same thing, we're going to do the training test and defining actually the training set and the test set. This library is using a slightly different organization for the training set and test set. It combines the X and Y together into a matrix and using as an input. So we do the same thing using XGBoost decision matrix, okay, using X-trend and Y-trend, and the test is the D matrix using X test and Y test. All right, so this is what we do. And then this some of the parameters for this running this. We'll talk about this later. And set up the model, fairly easy. And then we're going to run the prediction and print it out the outcome, precision, recall, and accurate. Again, we can print the so-called confusion matrix and print the so-called classification report using this the Y test portion against the prediction. Actually, so this gives you a slightly better solution than almost identical solution than the random forest, but for large problem this is a little bit more accurate, and it's being used quite a bit. Finally, and this section I have further exploration of XGBoost as a gradient boost, and I tune some of the possible parameter giving possible value in a list, okay, and I want them to try so-called grid search on the so-called hyperparameter, see which one gives the best solution, and I can export the models into a text format and comparing which parameters are giving better result. So this is more of a hyperparameter method. I'm not going to, it takes about 5 to 10 minutes on my computer, and takes about 20 minutes on my older computer. So it is a so-called time-consuming process. I'm not going to illustrate it here, but I give you the code right here in to show you how we can actually search for the better parameters for the so-called gradient boost classifier. Last, we can also use in the gradient boosting classifier from SciKit Learn library. And here I'm using, giving you an example how we can import the libraries also in the ensemble portion of the SciKit Learn, so-called gradient boosting classifier. Okay, and define the model, fit the model, and then using X trend and Y trend, and predict the model using the X test and giving out a score. And also I can print out the precision and recall and accuracy numbers altogether. And printing out the confusion matrix, either using heat map or just the numerical form. The last part is about printing out the classification report. These are fairly standard. And so this part of the scikit-learn actually giving a very decent outcome result. Finally, I'm trying to explain what is the recall and precision. And here we have a discussion about so-called false negative and true negative and true positive and false positive. So giving you the definition of the precisions actually equals to definition of a precision actually is true positive divided by true positive and false positive. So if you your model predict is positive but actually is false, so plus is the correct classification. We call it true positive, and as a denominator, and this we call the precision. And also a true recall basically means if I added the true positive and false negative together and as a denominator, what is the percentage of true positive we have? And this is what we call the recall. So these are the explanation over here, and I want you to kind of understand. All right. So, and also the F1 score equals to basically true positive divided by true positive plus 1/2 of false positive plus false negative. So this is usually the F1 score. Actually, this classification report show F1 recall precision and also other definition we have in this table. So accuracy equals to true positive plus true negative divided by total population, and so on and so forth. So these are the explanation. For detail you can go over. I'm just going to quickly conclude this lecture note on notebook, how to using Python to run on decision tree, random forest, and gradient boost decision tree using XGBoost library. Also, we can using the scikit-learn library as well if we want to. Both of them give us a similar result, and also we'll talk about later on in the exercise project, we'll talk about variation or parameter tuning for this gradient boosting classifier. And the gradient boosting classifier of the scikit-learn has less parameter for tuning, so it's less popular to use when you're using gradient boosting. However, the XGBoost library, actually you can do a so-called Greek search, basically hyperparameter search, using a variety of parameter for each category, and to search for the best parameter in classification. These are good for large, more complicated case example on data set. Later on, we're going to have you to try in the exam or the homework. I don't remember, using a so-called lending club data set for loan, and they offer or decline, and finally, if they issue the loan, actually what for what purpose, and what is the FICO scores, and what is the rate of or possibility of a loan for default, which is they cannot afford to pay the loan. So we're going to talk about more complicated, and I think we have about 1.3 gig of data set for you to try. So be prepared. Your computer should have plenty of memory to run these example with large data set, and the classification will be much more involved. So for now, I'm going to conclude this lecture. We'll see you in the next lecture.